Hi. Okay. Miss LeVan's finally doing some content on the YouTube channel. First time in like 100 years. I'm not going to lie. This gives a lot of flashbacks to remote learning. So, yikes. Okay. Welcome to the LeVan household. Office on TV, obviously. That's pretty much it. Nothing exciting. Okay. So, the purpose of this video, number one, is for my algebra kids in 8th period. So, if you're in my other classes, feel free to watch, but you don't have to. We're going to go over two examples with just application problems for equations, and then two examples with 2.5, which are those literal equations that we've been spending literally like 100 years on. So here we go. What I usually do with kids during a review video is I'll kind of put up the problem and hopefully you can pause it, work it out yourself, and then go from there. Or you can kind of just watch me go through. This is the first time using my trackpad again since remote learning. So just bear with me a little bit. It might take me a hot second to get back in the groove of it. Okay, so topic number one are just application problems for solving equations. So here's the first one. What is the radius of a circle with a circumference of 15 feet? And we're going to use 3.14 for pi. So what you're going to do here is that you, number one, are going to write out the formula. So circumference equals 2 pi r. If you ever forget, Miss LeMan shared with you that rhyme, twinkle, twinkle, little star, circumference equals 2 pi r. There you go. We know that we're going to use 3.14 for pi. So in a second, I'm going to rewrite it with 3.14. We're also given the information that the circumference is 15 feet, and then we're looking for r. So let's rewrite that formula and plug in what we know. So we know that the circumference is 15. So I'm going to take out my c and I'm going to plug in 15. I still have 2. Instead of pi, remember we're going to use 3.14 as directed by the problem. And then we don't know what our radius is, so we're going to leave that as the variable. Now, our goal is to get the radius or r by itself so that we can determine what it is. Because these two pieces here are being multiplied to r, to isolate r, we have to do the inverse operation, which means that we're going to divide both sides by 2 times 3.14. Now, I just know in my head, and you'll have a calculator too, 2 times 3.14 is 6.28. So if we consolidate these at 6.28, and then these cancel, and you're left with r, and then on your calculator, you'll do 15 divided by 6.28. I do not have my calculator nor my phone by me, so you go ahead and calculate that. Actually, hold on. Okay, here we go. All right, so in your calculator, you would do 15 divided by 6.28, and it's asking you to round to the nearest hundredth. So if you do that accurately, you'll have 2.39 feet, okay? Because remember, we're talking about feet. And then if you ever round, we use this approximately symbol. So in this problem, all we did is we rewrote our circumference formula, we plugged in what we knew, and we solved for r. And we found that our radius was approximately 2.39 feet. Moving on. Okay, to make up for Friday, Fish takes LeBan to a Drake festival. Fun times. It costs $12 to enter. So it's kind of like just like a flat fee just to enter the festival, $12. And then an additional $5 per t shirt. If they spend $27 total, how many t shirts did they buy? So, what we're trying to determine here is how many t shirts were bought. So, we need to set up an equation so that we can go ahead and solve. All right, so first thing, if we know that they spend $27 total, most of us know that we can kind of just set that up on the other side of the equal sign. It costs $12 simply to walk into the festival. Okay, it's not tied to anything. It's no matter what, it's just $12 to walk in. And then it's $5 per t-shirt. Just as a clue, when we're looking at word problems, whenever you see the word per, usually that means that there's going to be a variable coming after that. We don't know how much the t-shirts, how many t-shirts that we bought at this festival, which means that you're going to plug the X here, or you could do T for t-shirts, whatever you need to do. So we've got the $12 entrance fee. The 5, because it's $5 per t-shirt, we don't know how many they bought, equals 27. Then it just turns into a two-step solving process. We're trying to isolate x here to determine its value, which means that we need to move this 12 to the other side using inverse operations. If we see a positive 12, we'll subtract a 12. It's your inverse here. We have not touched the 5x here. And then when I do 27 minus 12, I get 15. And then it's just a one-step equation. We just divide by 5. And then to take it a step further, obviously x is equal to 3, but I would really like you to put that back in the context of this situation. So look back at what the question's asking you. It's saying how many t-shirts did they buy? So you would write me a nice clean sentence that says, Fish and Laban bought 3 t-shirts at the Drake Festival. All right. Moving on to the topic that we have spent 1,000 years on, and I never want to see lesson 2.5 again. So literal equations. So here's your first example. All it's asking is for you to solve the equation for x. That means that we want x by itself. Now, what I might even have you do on your formative or any in practice is just highlight that x so we know that that's what we want by itself. That's it. Step number 1 in isolating. You see that you have this denominator of p, which really is just showing you that you have division. We need to move that to the other side as our first piece. The inverse of dividing by p is multiplying by p. When you do that, division by p, multiplying by p, these cancel out. And we're left with what's in our numerator, that x plus m. And then on the other side, you just have p times a. Now, we still haven't gotten x by itself. We need to move this plus m to the other side to do so. So the inverse of plus m is minus m. Those go away. Now we do have x by itself, and then you're just going to rewrite this expression nicely. So you'll have p times a minus m, and that is your final equation. This was one of those sketchy ones where we're like, okay, we're doing math, but it's only variables. Okay. So if you are trying to isolate just a straight variable, my recommendation is to highlight it. And then you just need to use inverse operations to move your pieces around to get it by itself. Okay, that's fine. Solve the equation for m and then find the value of m for each value n. Remember, we're going to break this into 2 pieces. Step number 1, let's solve the equation for m. So here's what we've got. And again, we need this little m by itself here. Okay, so that's step 1. The first mathematical move that I can make is that I can take this minus 4n and move it to the other side. You have to use inverse operations. So if you see minus 4n, we've got to do the opposite, and we'll add 4n. These cancel. I haven't touched my 2m, so I'm just going to bring that down. And then here's what I have. And again, it doesn't matter if it's 8 plus 4n or you reverse it because addition is commutative. The last step, you see that you've got this coefficient of 2, which is actually attached to your m with multiplication. So to truly get m alone and to isolate it, you need to do the inverse of multiplying by 2, and we are going to divide every single piece by 2. That will isolate m for you. 8 divided by 2 is 4. 4n divided by 2 is 2n. And you have successfully solved that equation for m. Now we have to go to part 2, which is when we basically just substitute in these values for n. All right, so let's start with n equals negative 2. I always just rewrite this whole part of the equation. So you've got 4 plus 2n. And then instead of n, plug in that negative 2. 2 times negative 2 is negative 4. And when you do 4 plus negative 4, that actually cancels out, and that's 0. So that's your first one. The next one is that you're going to plug in a negative 1. So again, let's rewrite this 4 plus 2n. Hold on. Instead of my n here, I'm going to substitute in -1 because that's what the problem called for. So now I've got 4 plus -2, and then that just simplifies to 2. Your last one that it's asking for is for you to plug in 0 here. So again, let's see if I can extend my page. 4 plus 2n. So you still have that 4 plus 2n, and then you're going to replace your variable with the value it asked for. I know that 2 times 0 is 0. 4 plus 0 is just 4. So just as a really quick recap, this video, we talked about a few examples with application problems with equations where you kind of just had to read it, set yourself up an equation, and then just go through your solving process. Okay. And then we spent a little bit of time on lesson 2.5 with literal equations. One of those where we only had variables, no numbers, and we solved for a specific variable. And then another one where we had a few numbers in there. We solved for n, and then we plugged in values. Tomorrow in class, we're going to take some time and we're going to do our 2.1 through 2.5 study guide. We're going to do a review game, and then we can check in on anything. But you'll see on Schoology, I also uploaded this like express review video, like resource. It's on Google Slides. So it's there for you too if you need anything else. But thanks for tuning in. Please subscribe if you haven't already, and I'll see you tomorrow. Okay, bye-bye.